Scientific method. We always say observation is the first step of the scientific method. You see something that doesn't make sense, and then you ask a research question. All right? How does that happen? Why does that happen? Then you do your research. See if you can figure out what the answer is to that. Maybe someone has already done an experiment, and you could just end it right there if you're content with what their findings are. The main thing is, before you do that, or after you do your research, you create your hypothesis, because it is an educated guess. If you haven't done your research, then you are not educated in your guess. You're just making a simple guess. And so that's why it's important to do your research before you come up with your hypothesis. The hypothesis, of course, an if-then statement. The if part is the independent variable. The then part is the dependent variable. If I study longer, then I will get better grades. The if part is the independent variable. If I study longer, it's the thing that you do in the experiment. The then part is the result that you get. It's the then is the dependent variable. It's the result. So if I study longer, if you try to study longer, then the dependent variable will be what are your grades? Do you get better grades if you study longer? So that's how you set up your hypothesis. You, of course, can do your test. And then in your test, you have constants and control groups. The control group is the thing you set aside to compare your results to. It's under normal conditions, or if you remove the independent variable altogether. For instance, say you wanted to try to take the test without studying at all. That would be removing the independent variable altogether. Just to see, maybe the test is so easy that maybe the test would be like count from 1 to 10, and you really don't need to study for that. You just know it. So that would be the control group. You have a group set aside just to see if to compare your results to. If I was putting fertilizer on a pea plant, I don't know how pea plants normally get, so I would have a control group set aside with no fertilizer on it, just to see how tall a pea plant normally gets. If the control group is 2 feet tall and my experimental group that I put the fertilizer on is 3 feet tall, then I can say, hey, the fertilizer probably had an effect. But if they're both 2 feet tall, I would kind of be suspicious and say maybe the fertilizer didn't have much of an effect on it at all. All right. The constants are the things that you keep the same in every experimental group, and you want to try to keep as many things constant as you can possibly can. The idea is you want to isolate that one thing you're testing, whether getting the fertilizer matters or not. So you want everything else between those experimental groups to be the same, get the same amount of sunlight, same soil, same type of plant. You don't want anything to make a difference. The only thing that makes a difference should be the one thing that you're testing, the independent variable. And so, like with the if I study longer, then I'll get better grades. You should have different students taking the same test, the same age students, the same background of courses that they've already taken. So those will be the constants, and you want to try, if you can possibly keep the same, even things like you wouldn't think that you would need to. Hey, if you can, why not keep them the same? Have the students eat the same breakfast that morning, watch the same television shows the night before. Obviously at some point you have to draw a limit, but try to keep as much the same as possible. And then finally, your conclusion is going to be, do you reject or support your hypothesis? Did you get better grades when you studied longer? In which case you would support your hypothesis. If you didn't, you would reject your hypothesis. Note that there's nothing in here about proving your hypothesis right or wrong. Science is repeatable, and anything can happen once. And just because I study for a long time and pass a test one time, that doesn't mean you've proven your hypothesis. You've gained some support for it, but it needs to be done over and over and over again. And then if people keep getting the same results, that yes, hey, studying longer does get you better grades, then you would have a lot of support for it, and then you would turn your hypothesis would then become either a law or a theory, depending on whether it describes what happens. In this case, it would probably be the law of studying, or it explains why it happens. That would be the theory of studying. It would say why studying longer would increase your grade.